Have you ever wondered how keystroke recognition works? This fascinating technology is all about understanding and interpreting the unique ways we interact with our keyboards. It's like a digital fingerprint. In the tech world, it has immense significance, being employed in areas like biometric identification, fortifying cybersecurity measures, and analyzing user behavior. It's an unseen marvel that works silently in the background, ensuring a safer and more personalized digital experience. So now, you might be asking, how does keystroke recognition actually work? It all begins with capturing the keystrokes. The first step towards understanding keystroke recognition is understanding how these keystrokes are captured. It's a fascinating process that involves recording the keys that are pressed on a keyboard. But it's not just about which keys are pressed, it's also about when they're pressed. You see, the timing information associated with these keystrokes plays a crucial role in this process. The time it takes for a key to be pressed and released, or the latency between two keystrokes, can be as telling as the keystrokes themselves. This timing information is meticulously recorded and stored alongside the keystrokes. This data, the keystrokes along with their timing information, forms the raw material that we use to unravel the magic of keystroke recognition. It's a bit like a detective piecing together clues to solve a mystery. Once these keystrokes are captured, we can move on to the next step: feature extraction. With the keystrokes captured, it's time to extract the features. Now, what does this mean? To put it simply, it's about identifying specific characteristics from the captured keystrokes that will ultimately help us in recognizing patterns. Two key characteristics that we look at are the dwell time and the flight time. So, what's dwell time? It's the duration a key is pressed. Each of us has a unique rhythm when typing. Some of us are quick, hitting keys in a rapid-fire manner, while others might be a tad slower, pressing each key deliberately. Then there's flight time, the duration between releasing one key and pressing the next. Again, this varies from person to person, creating a unique typing pattern that can be leveraged for recognition. By studying and extracting these features, we're essentially creating a fingerprint of a user's typing style. After extracting these features, we can proceed to create feature vectors. Now that we have our features, we can create feature vectors. So, what exactly are feature vectors? Picture, if you will, a simple array of features that represent our keystroke data in a more digestible format. These arrays, or feature vectors, allow us to condense complex keystroke data into a more manageable form. Think of each keystroke as a unique ingredient in a recipe. Alone, each ingredient has its own distinct flavor and texture. When combined in a certain way, they create a unique dish. Similarly, each keystroke has its own distinct characteristics. When combined into a feature vector, they create a unique representation of the keystroke data. This process of creating feature vectors is crucial as it prepares our data for the next stage, model training. It's a bit like prepping your ingredients before you start cooking. It makes the whole process smoother and more efficient. Having our feature vectors ready, the next step is to train a one-class model. With feature vectors in hand, it's time to train our model. Now, the one-class model we're working with is quite interesting. It's designed to recognize the unique keystroke patterns of a specific user. To train it, we feed it the feature vectors we've created. These vectors, rich with information about each keystroke's timing and pressure, help the model learn what normal typing looks like for our user. Over time, the model becomes increasingly proficient at identifying this user's keystroke pattern. This training process is like teaching a dog new tricks, except our dog is a sophisticated machine learning model, and the tricks are intricate patterns of keystrokes. Once the model is trained, it's time for the final step, user authentication. Finally, we reach the stage of user authentication. With our trained one-class model at hand, we can now utilize it to authenticate users by their unique keystroke patterns. Picture this: when a user types on their keyboard, the model compares the incoming keystroke pattern with the one it has stored. If the patterns match, voila, the user is authenticated. This is because the model has learned to recognize the distinct rhythm and cadence of each user's typing style. It's akin to identifying a song by its unique melody. However, if the patterns aren't in harmony, the model raises a flag, denying access. And that, my friends, is how keystroke recognition works. It's a fascinating blend of technology and human uniqueness, don't you think?